Hello friends, in this clip we'd like to see how KC relates with KP, the relationship between KC and KP, and the whole of it is termed as equilibrium constant. So given a reaction A plus B forming C plus D, so this arrows tells you that it is a reversible reaction in that as products are formed, reactants are also formed. So that means A and B react to form C and D. At the same time, C and D react to form A and B. Initially, at the start of the reaction, we do not expect to have products. But then at equilibrium, the concentrations of both reactants and products are equal, but the reaction continues. So from Kp is equaling to the partial pressure of products raised to the appropriate powers divided by the partial pressures of reactants all raised to the appropriate powers. Now, from ideal gas equation, which is PV equals nRT. Now, if you try to make P the subject, P will be equaling nRT out of V. So this one can be written as P equaling to N out of V RT. But this one is equaling concentration. So we can replace N out of V with concentration. We have P equaling to C RT. So T is the temperature in Kelvin, R is the ideal gas constant, C is the concentration, P is the partial pressure. Now we substitute this one instead of partial pressure here. So we shall have C, concentration of C times RT times the concentration of D times RT divided by the concentration of A times RT times the concentration of B times RT. The whole of this one equals to Kp. Now, from the rules of indices, if you have 2 power x times 2 power y, this is the same as 2 power x plus y. So that means concentration of C times the concentration of D, the whole of this one is multiplied to RT power M plus T, the whole divided by the concentration of A times the concentration of B, the whole of this one is multiplied by RT power X plus T. Now back to the rules of indices. If we have 2 power X divided by 2 power Y, this one is the same as 2 power X minus Y. So, in other words, this means that we shall have the constant. Remember, the whole of this one is equaling to Kp. So that means we shall have concentration of C multiplied by the concentration of D out of concentration of A multiplied by the concentration of B. Kp is equaling to this one, the whole of this one is multiplied by RT power M plus T minus X plus Y. Excuse me, this is Y. Now, From here, you can see from Kp is equaling to the concentration of products, Kc out of concentration of reactants, where these ones are products from our equation. These ones are products and these ones are reactants. That means this one is equaling to Kc. Therefore, Kp equals Kc times Rt power m plus T minus x plus y. So therefore, Kp, in other words, m plus T are powers on the product, x plus y powers on reactants. So that means Rt our change in N, where N equals M plus T minus X plus X. So here it means Kp will be equaling to Kc Rt power change in N. So in summary, it is like this relationship between Kc and Kp. Given a reaction A plus B giving C and D, where in balancing A is X, B is Y, C is M, D is T. So from Kp equaling to partial pressures of the product of partial pressures of the products divided by the product of partial pressures of reactants, all raised to the appropriate powers, you get that. So but PV, the ideal gas equation, PV equals nRT. So that means if you have to make P the subject, P is equal to nRT out of V. Remember, nR out of T is equal to concentration. So we substitute concentration instead of N out of V. P equals CRT. So we substitute CRT in position of partial pressure. You will have that one. So by introducing the rules of indices, you will have that one.